Welcome back to this video tutorial. In this video, we can consider some program examples in order to understand the structure concept properly. So here we can consider one program in which we have a structure with name student. The student structure actually used for storing the details of a student. What are the details we needed here? We need the name of our student. So here we have one member of this structure for storing or representing the name of student, which is a character array. Another is for indicating the identity number of a student, like our roll number, admission number, etc. Here we have one integer variable or integer member SID for indicating student identification number. Then here we have three floating point variables M1, M2, M3. These are used for representing three different marks of three different subjects of a student. That means the mark obtained for three different subjects for a particular student. Now consider this variable, structure variable declaration. These are about the template of our structure student. Now here it is the structure variable. How it is declared here? It is declared as an array. Stud of 50. What is the meaning? Here it declared total 50 number of structure variable. This is the difference of structure variable declaration from our previous example. In our previous example, we have declared only a single structure variable. But here it declared, using this single statement, here it declared how many structure variables? Total 50 number of structure variables. What are they? First one is stud of 0, stud of 1 up to stud of 49. Based on the indexing value, we can represent these 50 number of student variables like stud of 0, stud of 1, stud of 2 up to stud of 49, or some other times we can represent, or if the indexing is starting from 1, then the variables become stud of 1, stud of 2 up to stud of 50. Okay, so here we have declared a total of 50 number of student structure variables. What is the meaning of that? That means while creating or declaring various structure variables, here it perform memory allocation for the first student, that is stud of 0. Okay, for that particular 0 student, here we need memory allocation for its identity, for its name, and for storing mark for three different subjects. Right? Okay, similarly for the student 2, that is stud of 1. Here we need the same set of memory allocation separately for representing the identity of our second student, the name of the second student, mark of three different subjects. Okay, so this set of memory allocation needed for our first student, which is accessed using this object or using the structure variable stud of 0.sid, stud of 0.sname, stud of 0.m1, etc. All these are actually indicating the members of our first student. And all these are indicating stud of 1.sid, stud of 1.sname, etc. actually pointing to the members of our second student. And stud of 2.sid, stud of 2.sname, etc. actually indicating our third student details. Okay, for that, while creating 50 such student structure variables, here it performs separate memory allocation in our system memory. Okay, keep that particular point in your mind. For creating or declaring a 50 number of student structure variable. While creating such 50 variables, here it performs separate memory allocations in our system memory for each and every structure variables. So, for the first student, we need this much of memory allocation, one for indicating an integer student ID and 20 consecutive bytes for representing first student's name, and different bytes are needed for representing 3 different marks. Similarly, the same amount of memory allocation separately needed for representing or storing the name, ID and marks of our second student, and for third student, and so on. And finally, total we need 50 such memory allocations, 50 such group of memory allocation in order to store details of 50 different students. Okay. This particular group of memory allocation indicate the details of our first student, and this particular memory allocation used for storing the details of our second student, and so on. So finally, the same amount of memory allocation required for storing our 50th student details. Okay, so this is the case of declaring more than one structure variables. We can use this array syntax for declaring more than one structure variable of the same type. Okay, so this is the syntax for declaring more than one structure variable of the same syntax. So the structure variable declaration becomes simple for the programmer here. With this particular syntax, the structure variable declaration, using this particular syntax, it declares 50 different group of memory allocation, each for 50 different student details. So the member variable allocation or member variable declaration means that separate memory allocation for 50 different student become easier here. Okay, so using this, now inside this main we can read values from our keyboard. First is the number of students in your class. If your class with having 50 number of students, then we can read the limit as 50. Suppose your class is with only 30 number of students, then we can read 30 as the limit here. Using that particular limit, we can initialize each of these allotted memory space. For the first student, we can initialize the ID, the name and 3 different marks. Where these values get loaded into this particular allotted memory space, because initially I value equal to 0. So this particular address actually pointing to the location of stud of 0.sid. That means this particular memory location. Okay, and this is the syntax for reading name of our first student. We don't want to use this ampersand here while reading the string. Okay, this is a syntax for reading a string using this scanf statement. We don't want to specify the address because the character array, the name of the character array always indicating the starting address of our array. So the name itself indicating the starting address of array, we don't want to use the ampersand symbol here. Simply use the name. That is why stud of 0.sname. Stud of 0.sname actually pointing to this particular memory location, in which we can store the name which is entered through the keyboard, which is stored here in this particular location. Then we read 3 different marks which are stored into location pointed by stud of 0.m1, stud of 0.m2, stud of 0.m3. These are the location pointed here. Okay, after that increment the I value by 1 and reading the second set of student details. All these are actually representing the details of our second student. That is stud1 dot sid, stud1 dot sname, and stud1 dot m1, stud1 dot m2, stud1 dot m3. All these are pointing to another set of memory allocation represented here. Right, then after incrementing I again, it pointing to another set of memory allocation, which is represented with the label stud2 dot sid, stud2 dot sname, stud2 dot m1, stud2 dot m2, stud2 dot m3. Okay, all these set of variables actually indicating the memory allocation used for representing the third student's details. Okay, and finally this particular set of memory allocation indicate the details of our 50th student, which all pointing to the name, ID and marks of our 50th student, last student of this class. Okay, so this is the case of declaring multiple structure variable in single step by following this array syntax. Each and every entry of this stud array indicate different student structure variable. Okay, so this is the syntax for declaring multiple structure variable in a single step. Stud of 50 indicate 50 different structure variable. Okay, that 50 different structure variable actually representing a group of memory allocations. Okay, so total a group of 50 such memory allocations are needed. In each group we need a memory allocation for representing the sname, memory allocation for representing the ID, and memory allocation for representing 3 different marks. Such 50 different groups are allotted here in our system memory. Okay, so this is the meaning of this particular syntax. Now we can consider one program example. We can generate the code and execute such a program. Okay. So consider this structure student with the same members S9, then SID and 3 different mark along with another variable total. This total is actually for accumulating the sum of these 3 marks. Okay, how many structure variables are created here? Total 50 structure variables are created here. We can represent each of these 50 variables starting from indexing 0, like stud of 0, stud of 1, stud of 2 up to stud of 49. Total 50 such memory groups, memory allocations are created, and in each memory group we need separate space for representing name, ID, marks and total. Okay, now in this we can read the limit of number of students, that means total number of students present in your class. So that limit is available here in this particular variable now. Now we can enter the student details. So inside this loop, we can read ID, name and marks of 3 different subjects one after another from the keyboard, and we can initialize different structure variables separately. While initializing different structure variables, we can initialize separate group of memory allocation. That means first case, it allowed the first ID value read from our keyboard is stored into stud of 0.sid, a particular memory location pointed by the variable stud of 0.sid. Second one, the name read from the keyboard is loaded into stud of 0.sname, another memory label pointed by this variable stud of 0.sname. After that, read three different marks one after another and are loaded into stud.0.m1, stud.0.m2, stud.0.m3. Three different memory location pointed by this variable stud.0.m1 and m2, m3, etc. And we can also initialize the total value of or total mark of our first student, that is stud.0.total is initialized as a sum of these three marks. That is why stud.0.m1 plus stud.0.m2 plus stud.0.m3. So the same repeated for total number of students. So the allotted separate group of memories are initialized with the values read from our keyboard. So consider this particular syntax of reading string from keyboard. Here we don't want to use the ampersand symbol because the S name is actually a character array. An array name actually pointing to the starting address of our array elements. So stud of i.sname directly pointing to the starting address of that array. So we don't want to use this ampersand symbol here. Simply use the name of our name sname here. That is enough for reading a string and initializing a character array. Okay. Now we can display all these details in a tabular form with the help of this for loop again. So here we can display table header like SID, SNAME, M1, M2, M3 and total, and in each row we can display the details of different students one after another. First, in the column of SID we can display the first student's ID, in the second column the name of the first student, and in remaining three columns we can display mark 1, mark 2, mark 3 of our first student, and finally display the total of our total marks of these three subjects of our 0th student or the first student. After that, we can display the details of our second student in the second row, third row, and repeat until all the students' details are displayed. Okay, so now we can execute this. Chapter 3. The limit or number of students in our class is 3. And then ID is set as 1 for the first student, name is put as A, mark the three different marks of the student A is 1, 2, 3. And student ID of second is put as 2. Set the name as B, mark as 2, 3 and 4. Student ID is put as 3, name as C, mark as 3, 4 and 5. So all these are displayed here. First, the first student ID 1, next 1, thus name of first student, mark 1 of subject, first subject's mark, second subject's mark and third subject mark of our first student and its total. Second, the ID of second student, name of second student, three different marks and its total. Third, the ID of third student, name, three different marks and its total. All these are displayed in a tabular format here. Okay, so this is the case of using structure variable of multiple, that means declaring structure variable, multiple structure variables in a single statement. So this particular statement make the task of declaring multiple variables, make this particular task easier for the programmer. So this particular statement indicates that creating variables for 50 different students and each student indicate this much amount of memory allocation. A character array with 20 size and integer for representing the ID and three different memory space for representing marks as float and for finding the total of these three different marks. All these amount of memory allocations are required for each and every student variable. And this simple statement, this simple student structure declaration indicate memory allocation for 50 such students. Okay, so using this loop we can access the memory space for each and every student separately, and we can initialize value, and also we can access value separately for each and every student using this particular index. Okay.